Welcome to Coordinate, and today we want to understand the shortest job first scheduling algorithm. Now the second type of it, we said shortest job first can either be preemptive or non-preemptive. Hence we want to understand how can we implement shortest job first on a non-preemptive scheduling algorithm. The only difference with our previous session is with non-preemptive scheduling algorithm, the CPU doesn't need to be switching from one process to another, checking is there the shortest one in the ready queue which can represent the running one. No. Non-preemptive, meaning if the CPU is allocated to a certain process, then definitely the CPU will proceed the execution of that process until it is terminated or until it reaches a waiting state. So let's see this example, and then from here we'll see how we can analyze shortest job first scheduling algorithm if we are to be given a certain question or a similar question in an exam, or if we are to be given a similar question simply as an example or an exercise in, of course, a class or something related to that. So we've been given 4 processes. We have process 1, process 2, process 3, and process 4. Their respective best time or execution time is simply 7, 3, 10, and 2 respectively. Now, we've not been told the actual waiting time for each of the processes, no. So meaning, if you are even to be given such a question, please just take note that the default arrival time for each and every process is 0. Meaning they all arrived in the ready queue at the point when the CPU was just up and yet to start running, meaning at point 0, at 0 milliseconds. So if we are to say what is the actual waiting time for process 1, it's 0, process 2 0, process 3 0, process 4 0. So the question is, okay, based on the actual best time that we've been given, calculate the average time for all the processes. For we to calculate the average waiting time for all the processes, that means we need to calculate the actual waiting time for each and every individual process, and then from there definitely we need meaning to even plot a Gantt chart that will allow us to understand, okay, this is the actual performance, this is the actual visualization of the processes and how they behave. So let's then extract the actual waiting times from the Gantt chart that we'll plot. So here is the Gantt chart. Don't forget, we said since we've not been given the arrival time, then we'll just take note and denote that the actual waiting time for each and every process is 0 millisecond. Hence, they are all in the ready queue at point 0. So, shortest job first. Once the CPU is given a process, no need to take that process outside the CPU for as long as that CPU is already working on that process. The only time when the CPU will start working on another process, it's the time when the process that was running in the CPU has been terminated, or the time when that process is now in a waiting state. So we have these processes. So shortest job first, shortest job first. I'm sure you can tell which one has the shortest job first based on the best times that we have or the execution that time that we have. Definitely we would say, okay, process 4 execution time is less compared to process 1, process 2, and process 3. Hence, process 4 should take the CPU at start. Shortest job first. It's not longest job first. No, shortest job first. So definitely process 4 will execute for 2 milliseconds, and then by then process 4 will be removed in the ready queue, will be outside the ready queue. It has been terminated. It's complete. It has been executed completely. So on the remaining 3 processes now, which one has now the shortest job first? Definitely we go now to process 2. So on the remaining 3 processes now, we have process 1, process 2, and process 3. Which one has the shortest job first? Shortest execution time. Of course, we go to process 2. It has the shortest, it has 3 compared to 7 and 10. 3 is the smallest, shortest job first. Hence, process 2 takes the CPU now, starting from 2 milliseconds to 5 milliseconds. 3 plus 2, which is 5. And then from there, we can cancel out also process 2. It's outside the ready queue. The execution has completely been done. Which one now, between the two remaining processes, process 1 and process 3, has the shortest? Definitely process 1 has the shortest, hence 5 plus 7, which is the actual best time or execution time. This takes us to 12 as the actual point when process 1 completely got executed or terminated. And then from there, we'll ask ourselves, okay, which one again is, since process 1 is outside now, is out from the ready queue, which one has the shortest job first? I mean, the answer is process 3, because it is actually the remaining process inside the ready queue. So 10 plus 12, we go now towards 22. 12 plus 10, that's 22. Simply, this is now the actual Gantt chart that we had to plot based on the shortest job first scheduling algorithm on a non-preemptive. I mean, non-preemptive is less cumbersome compared to a preemptive one. I'm sure you can also tell. So we need to extract the actual waiting times for all the processes for we to come and use the waiting times for each and every process to find the average waiting times for all the processes. So process 1 actual waiting time is 5 milliseconds. It had to wait for 5 milliseconds here at this point for it to be executed. Process 2 waiting time is 2 milliseconds. I mean, double check. Process 2 had to wait in the ready queue for 2 milliseconds for it to be given the CPU and then to proceed with the execution. Process 3 had to wait for 12 milliseconds. I mean, this is the actual waiting time for process 3. And then from there, process 4 had to wait for 0 milliseconds because it was the first to start using the CPU. So to find the average waiting time, simply we add up all these values, the waiting times for each and every process, and then divide definitely by 4, which is the total number of processes. So this is the average waiting time. 5 plus 2 plus 12 plus 0, and then we divide by 4, which gives us 4.75, of course, as the total average waiting time, which is in milliseconds for all the processes. So this is the information that we can present on shortest job first for now when it comes on a non-preemptive scheduling algorithm. Let's proceed on our next session as we understand now a newly to be introduced scheduling algorithm, which is round robin scheduling algorithm here on CodeNet. And please don't forget to subscribe, and of course we are still on our way to the entire full course of operating systems. Please don't forget you are on CodeNet.